You absolutely have to know how to solve this problem. It's guaranteed to be on the test. Let's look at the question. The problem asks us to compare the sizes of two numbers. The two numbers to compare are 2 to the 33rd power and 3 to the 22nd power. For these two numbers, the bases are different. One is 2, the other is 3. And their exponents are different too. One is 33, the other is 22. Usually when we compare numbers like this, either the bases or the exponents should be the same. Otherwise, it's hard to compare. So what should we do? Since they're not the same, we need to find a way to make one part of them the same. For example, let's look at the exponents, 33 and 22. Actually, they're both what we call repeated numbers. What does that mean? It means that each digit in the number is the same. So for numbers like this, we can try to break them down. For instance, take 33. The base, 2, stays the same, and 33 can be broken down into 3 times 11. All right, next, for this one, its exponent is 22. The base, 3, stays the same, and the exponent can be broken down into 2 times 11. Look, this one has an 11, and that one also has an 11. We said that the parts that are the same shouldn't be changed, right? So next, how should we adjust them? We turn it into 2 to the 3rd power, and then raise that to the 11th power outside the parentheses. So, what do we turn this one into? Here, 3 squared and then raised to the 11th power outside the parentheses. Even though we've added parentheses, the result is the same as above, right?
So what's the benefit of doing it this way?
How do we calculate 2 to the 3rd power? Isn't 2 times 2 times 2 just 8? So here, it becomes 8 to the 11th power. And next, what does 3 squared mean? 3 times 3 is 9, right? So it becomes here, 9 to the 11th power. Which is bigger, 8 to the 11th power or 9 to the 11th power? Isn't this one bigger? There, once you fill in the symbol, the answer to the question is done, right? I suggest everyone give this a like, save it, and watch it a few more times. Otherwise, if you want to use such a handy method again, you might not be able to find it.